Alright, this is 5.4, Writing and Graphing Compound Inequalities. The first thing we're going to do, similar to what we did prior lesson, is translating verbal phrases into an inequality. However, this time it is a compound inequality. So number one, all real numbers that are greater than negative 2. So to represent greater than negative 2, numbers that are greater than negative 2. However, they are also less than 3. I can turn this into a compound statement by saying that x is in between negative 2 and positive 3. Now, if you notice, my signs are both going the same direction. That is important. You need to have your signs going the same direction. So the statement is the same. All right, number 2, all real numbers that are less than 0 or greater than or equal to 2. So all real numbers that are less than 0 or they are greater than or equal to 2. Now, this statement I cannot turn into a compound inequality like this one because it is an or. If I were to graph it, less than 0 would put me this way. Greater than or equal to 2 would go that way. So they don't have anything in common. Unlike this statement up here, if I were to graph it, x is greater than negative 2 would go that way. Less than 3 would go in. So I have a compound comparison right there. They have something in common. All right, go ahead and try these two problems on your own. All right, solving a compound inequality with the term and. Now, with this, we can separate it into two statements. You can say 2 is less than x plus 5, and then x plus 5 is also less than 9. And solve them individually. So subtract 5, negative 3 is less than x. Come over here, subtract 5, x is less than 4. And you can just bring them together to say negative 3 is less than x is less than 4. However, sometimes people can actually visually see that you do it from the very beginning, which kind of saves a step. So let me show you that way real quick. Subtract 5 from all sides. So I'm going to subtract 5 from my 2 and get negative 3 is less than x. Subtract 5 from my 9 and get 4. So it actually simplifies the step. So go ahead and try this one on your own. And this one is a little bit more complex. It is a two-step. You should notice that it's not only a minus x, but it's also, or a negative x, but it's also a minus 3. So there's two things you need to get rid of to solve. So go ahead and try that one. Okay, now an or statement. Or statement, very similar, however, it needs to stay as an or statement. You can't combine them as one. So again, we're going to solve for x by subtracting 3 on both sides. Divide by 2. X is less than 3. Over here I add 6. So I have 3x is greater than 18. Divide by 3. X is greater than 6. It is an or statement. So to graph it, I don't know where that came from. X is less than 3 goes that way. X is greater than 6 goes to the right. Okay? So let me step back here because I did forget to graph my solution. It is showing that x is in between negative 3 and 4. Both of them are open because they're not equal to. So x is in between those two. All right, so now this concludes the podcast 5.4, Graphing and Writing Compound Inequalities.